So what we're going to look at today is disposing of polymers. And polymers are really, really useful, but they have one really large drawback, and that is the fact that they're very difficult to dispose of. So synthetic polymers have loads of advantages. So they're incredibly widespread these days, and we take them really for granted. There's so many things like shopping baskets, helmets, cups, pots and pans have polymers. Even if they're not fully just made of polymers, they'll have polymers on them somewhere. Lots of pots and pans are coated in polymers to make them non-stick or scratch resistant. Polystyrene heads, fans, all sorts. But they're hard for us to get rid of. So we have polyalkenes, and polyalkenes, so things such as polyethene, polyethene, polystyrene, they're addition polymers, so polyalkenes. And they're made up of non-polar carbon chains. And these non-polar carbon chains make them pretty unreactive, and they're chemically inert. This is a huge advantage when they're being used. So, for example, if you're using a polystyrene cup to have coffee, to drink coffee out of, the polystyrene cup won't react with the coffee. But it has a disadvantage of making them non-biodegradable. Condensation polymers, so things like polyesters, polyamides, these do have polar bonds in their chains, and that makes them open to attack by nucleophiles. So because of this possibility, that means that condensation polymers can be broken down by hydrolysis. So these polymers are technically biodegradable, but it is a very slow process. It's not something like we pop it in the earth, 2 days later it's gone. It's a slow process. So we have to think of a way to deal with these waste plastics. It's estimated that in the UK, we throw away around 3 million tonnes of plastic, so synthetic polymers, every year. And that's because plastics either take a very long time to biodegrade, so condensation polymers, or they're non-biodegradable, so polyalkenes, addition polymers. The question of what to do with all of these plastic objects when we've finished using them is an important one. So we've got a few options. We can bury, we can burn, or we can sort through reusing and recycling. But that's a bit more of a complicated process. So if we sort of talk through it here, so we've got our waste here, we could straight away get rid of it and bury. We could get rid of it straight away and burn, or we can sort. Now, when we sort it, some will get sorted and we can remold, and we can remold them into other plastics. So then we get new objects. Or when we sort them, they can go through cracking. And when they go through cracking, they then have to get processed, and some become other chemicals because we can't use them as polymers anymore, or we can make new polymers, so we can make new plastics with them. And that's the sort of process that we can go with. So let's look at burying them first. What happens if we bury them? So there's disadvantages and advantages to all of these options. So let's look at burying. Oops. So landfill. Landfill is one option for dealing with waste plastics, and it's generally used when it's difficult to separate from other plastics. So when the plastic that we've got is really difficult to separate from other waste. It's mixed in with too much waste, we can't separate it, or it's molded into an object where it'd be too hard for us to separate. We don't have enough sufficient quantity to make separation financially worthwhile, or technically it would be too difficult for us to try and recycle it. Advantages of landfill: it's really cheap and it's really easy, but it requires large areas of land. As the waste decomposes, it also releases methane. And as we know, methane is a greenhouse gas. And also we can get leaks from landfill sites, and these can then go and contaminate water supplies. The amount of waste we generate is becoming more and more of a problem So there's a need to reduce landfill as much as possible. So burying waste plastics really isn't a solution. So then what we look at is burning. So can we use burning? So burning waste plastics can be burned and the heat used to generate electricity. So I think, oh, that's great. We can do two things, get rid of it and get some electricity. However, we have to really carefully control this to reduce the release of toxic gases. So, for example, polymers that contain chlorine, such as PVC, produce hydrogen chloride when they're burned. So this has to be removed. So waste gases from the combustion are passed through something called scrubbers. And these scrubbers can neutralize gases such as hydrogen chloride by allowing them to react with a base. But for waste gases, for example, carbon dioxide, still are going to contribute to that greenhouse effect. So let's look at recycling then. We go, well, recycling must be the most obvious one. Well, let's have a look at some of the issues with recycling. So recycling waste plastics. Because many plastics are made from non-renewable oil fractions, it makes sense to recycle plastics as much as possible. There's more than one way to recycle plastics after sorting into different types, so we have to sort them first. Once we've sorted them into different types, we can melt and remold some. So things such as polypropylene can be melted and remolded, or some can be cracked into monomers, and these can then be used to make more plastics or other chemicals. You sometimes see with plastic products on the bottom, they're marked to make sorting easier. So it's something that we don't really pay attention to as consumers, but you'll sometimes see little symbols like this, and it will have a 3 and an arrow like this and a triangle. So that'd be PVC. And it tells them what the different polymers are. So it tells people what that plastic is made up of. So people who are recycling it, they know what to do with it. And then 5 is polypropylene. So that often lets us know if they can be recycled later on. So like other disposal methods, there's advantages to it, but there's still disadvantages to recycling plastics. So one advantage is it reduces landfill. It reduces the amount of waste that goes to landfill. It also saves raw materials, and that's really important because oil is non-renewable and lots of polymers are made from oil fractions. This one is really, really, really important. I mean, they're all important, but that one's quite important because when we think about oil, our oil obviously is non-renewable and polymers often come from oil fractions. The cost of recycling plastics is often lower than making the plastics from scratch, and it produces less carbon dioxide emissions than burning the plastic. However, disadvantages, it is technically difficult to recycle plastics. Collecting, sorting, and processing the plastic is more expensive than burning or sending to landfill. That says expensive, I mean expensive. You often can't remake the plastic you started with, so you have to make something else. And the plastic can be easily contaminated during the recycling process. So what we're going to have a little look at now is a couple of exam questions based on disposing of polymers. So waste plastics can be disposed of by burning. Describe one advantage of disposing waste plastics by burning. Anything around the heat energy, anything that suggests around the heat energy produced can be used to generate electricity. Anything around that generation of electricity, You could also say, instead of saying that, you could also mention that it actually saves space on landfill. That's also important to remember. You're then asked to describe a disadvantage of burning waste plastics that contain chlorine and explain how the negative impact of this disadvantage could be reduced. So when we burn plastics, so burning plastics that contain chlorine produces toxic gases such as HCl. So that's the first part. And explain how the negative impact of this disadvantage could be reduced. So waste gases from combustion can be passed through scrubbers. And then explain what the scrubbers do, which neutralize HCl by allowing it to react with a base. And then that would get you the full 2 marks. Second question, give one advantage and one disadvantage of landfill as a disposal method for waste plastic. So one advantage, I'm going to do this in shorthand, but obviously you need to write in full sentences. So one advantage could be cheap and easy. You could also say doesn't require waste plastic to be separated or sorted, anything along the lines of cheap and easy. And then any sensible disadvantage. So I'm going to say requires large areas of land. Other ideas that you could say, releases greenhouse gases, or leaks from landfill, contaminate water. Any sort of sensible answer. Remember, you don't have to go overboard and give every possible advantage or disadvantage. It's just one advantage and one disadvantage. And then finally, I've said the diagram below shows sections of 2 polymers and I haven't drawn them on. So just give me a second and I'm going to magically make these polymers appear. Here we go, like magic, we've got the 2 polymers. We've got the diagram below shows sections of 2 polymers. So we've got A and we've got B. So you're then asked to state which of these polymers is biodegradable and explain why the polymer you selected is more reactive and can be broken down. So clearly in these sections, we're looking for a condensation polymer because they can obviously then go through hydrolysis. Looking at those 2, A is our condensation polymer, not B. So state which of these polymers is biodegradable, get your first mark, state A. Why? Why is it more reactive and can it be broken down? Well, it's more reactive than polymer B because it has polar bonds in its chain. So it can be attacked by nucleophiles and hydrolyzed. It's really important to mention those polar bonds because it's asking why is it more reactive. So because it has polar bonds in its chain, so it can be more easily broken down because it can be attacked by nucleophiles and hydrolyzed. That will get you the 2 marks. Then you're asked to name the type of chemical reaction that occurs when a polymer biodegrades, and that you've pretty much answered in the other question. So it leads you to it is hydrolysis. And that was an overview of disposing of polymers.